Welcome back. I was lucky enough to receive one of these new Bastl THYME Plus tape delay effect pedals from Bastl. I never had the original Bastl THYME, which came out a couple of years ago, and this is an updated version of it. It has a more substantial metal body. It's quite solid, very rugged knobs here that have lovely movement to them, improved buttons, and quite a few additional new features in the firmware. So what we're going to do is we're going to hook this up to my modular system. We've got stereo inputs, stereo outputs. We've got a MIDI control jack here, it uses TRSA, a foot switch, and a clock in and a CV in that work with modular levels. So let's get this hooked up to the modular, and we'll see what sort of sounds we can get out of it and what sort of crazy things it's capable of. So let's get started. Well, let's start with an overview of THYME. Like I do in most of my videos, we'll just do a quick walkthrough of the controls, and then we'll start getting it set up in a modular environment. The basic idea with THYME is it has a tape machine, and the tape machine has a read and a write head. The distance between the read head and the write head determines the delay time. So the relationship between those two heads and the speed of the tape gives you the time at which you will hear the echo of the sound that you play into it. And that's really the basics of it. That's how the delay function works. Starting on the left here, we have the input gain, which we can boost up the sound. Now, we're going to be setting up our gain staging just in a moment in the video because we're going to be sending Eurorack levels into this, which will just require some gain reduction. This knob here controls the tape speed, which is the rate at which this virtual tape is moving between the read and the write head. If you look at this picture, you'll see conceptually what we're talking about. The read head is at a distance from where the original incoming sound is written, and the speed of the tape is controlled by this knob, this virtual tape. Similarly, the delay time here is controlled by the distance between the read and write head. So if we increase the delay time, the distance between the read and the write head increases. So we've coarse control of that, fine-grained control of that. And the fine-grained control is nice because this allows you to build, for example, chorusing style effects if you have a very fast tape speed. The essence of any delay function, of course, is a feedback loop. And the feedback loop takes the echoes of what comes out of the read head and feeds it back into the write head. So you get those repeating delays. And so the amount of feedback is controlled by this knob here. If you turn it up too high, you'll get ever increasing amounts of feedback, which could be cool, might be what you want, especially when combined with some filtering or some other controls, because you can create drone effects that way. We've got a crossover filter here, low pass, high pass, and this is the inline with the feedback loop. The other nice thing is we can add more read and write heads here with these two controls. The spacing controls the spacing between the additional read heads, so you get extra delays. These are often called taps, so it's a multi-tap delay. You've tapped into the tape using these extra heads, and the level here is the level that these feed back into that feedback loop. Dry-wet mixes, as you'd expect, allows you to mix the dry and wet. If you want to completely stop listening to it, just hit the bypass button here. The bypass light goes on. It cuts out the effect, and you just hear the dry signal. We're going to use that in a second when we set up our audio levels. Now we come to the thing that really gives the THYME its power, and that is these things called robots, which are effectively LFOs, low frequency oscillators. Each of these knobs can have an LFO assigned to it. All of them except the input gain. It's set for the entire preset and stored in permanent memory. The other thing we can do is we can save all of these settings for individual knobs into different presets here, and these buttons by default, when you tap them, load a preset. The delay time can be clock synced using these sync buttons. Similarly with the tape speed can be linked to incoming clock. And of course, like all delays, we've got the freeze button here, so you can freeze the tape and just keep looping what you're having in the delay buffer. The other weird and wonderful thing about the THYME is all of these presets can be then played in a step sequence. So you've saved 8 presets of all different delay settings. You can now press play here and it'll step through them and play them as if they were being clocked along like a step sequencer. Okay, that's enough of an overview. Let's get setting this up. Now, to set up the THYME in a modular environment, there's 2 things we need to take care of. One is the audio path and the other is the clock path. So I already said we're going to use the clock input here on the back. So let's get that patched in now. And what we're going to do is patch it to the clock output here on the back of the Oxi One. And that's going to use a standard trigger clock that you would get out of any modular clocking environment. Okay, I've patched the clock into the output here of the Oxi One. The other thing we have to do now is choose the clock source. So to do that, we press Shift And the tap button allows us to choose between tap clock, clock input if the middle light is lit, or MIDI clock. So let's choose clock input. And then if I hit play, you'll see the clock light flashing here. And we're just hearing some drums there off the flame in the background. Okay, now we need to get audio into this and audio out of it. So let's look at the audio input path first. What I'm going to do is just take the audio straight out of the Warp oscillator here. Now, this is a very kind of unusual thing to do because we've got a big mismatch in audio levels between Eurorack, which runs at 10 volt peak to peak, and line level audio inputs over here, which are typically 1 to 1.2 volt peak to peak. So we'll start with the input gain all the way down. And the other thing I'm going to do is just go into the settings here on the Warp, and I'm just going to dial the output gain way down. Now that's something I can do on Warp because it's a digital oscillator. If you had a different oscillator, for example, if it didn't have this type of feature, you'd probably want to put some sort of attenuator on the other side of it that you could pull back the levels going into THYME. Alternatively, you could use some sort of send return module that automatically converts to line level and then brings it back in. But there's plenty of them out there. Now the audio that comes out of THYME has to come back into our modular because I do actually want to do a little bit of processing with it. So in this case, what I'm going to do is I'm going to use the inputs here on the KXA case from Nano Modules. This is a great case for this kind of thing because it's got both 1/4 inch audio inputs and 1/4 inch audio outputs that are able to map from line level to audio level. So now I can just take the audio here, the stereo, straight into the back of the case, and they come back out here boosted up to Eurorack level. Okay, let's start our sequencer now and get our audio levels right. Now, this brings me to these green LEDs that you see around the knobs here, and these show you the position of the value on the knob. Now, why not just look at the knob and you'll know where the position is? Well, remember, every knob can be modulated by an LFO or these robots. So this green LED is going to indicate to you what's going on with that modulation as well. In addition, when you first load up a preset, it will also show you what the current setting for that knob is. And you may have to turn the knob to catch that value and bring it back down. So you see there, the spacing was flashing green, and it didn't change until I caught the value and turned it back down. More importantly though, for our purposes right now, this input gain is going to go green or red, depending on if we're bursting through the input levels of the device. So let's take a quick look. At a certain point, that input level is just going to get too high. So for example, if I had the output gain much closer to just say -6 here, we'd have to have that dialed way down because it hit the red limiter much quicker. So I just it's all about a little bit of gain staging here. Okay, great. Now we have the audio path set up. Let's experiment with some basic feedback paths. And what we want to do first of all is just bring all of these down. We'll turn the tape speed down and the filter in the middle, just so we've no filtering going on. Make our level come up, and we've got our gain set over there. So we have our audio coming back in through QPass over here. We won't be doing any filtering on it just yet, but it's there set up on QPass so that we can actually filter and play around with it later on. We'll have a nice plucky sound here. Let's slowly bring up dry wet mix. Now I want to clock sync the delay, so I'm going to tap the sync button here. Now we hear classic delay coming in. And I'm going to go in and turn on an arpeggiator over here. Now say we only want to delay the high frequencies. we could delay only the low frequencies. Now, you might have noticed there that when I was playing around with that, and you can just jam away here and have a lot of fun with this, that the tape speed reacted instantly and sort of was like classic if you sped up a tape recorder. But you can link the tape speed to the incoming clock signal using this link button. So the sync button here is for the actual delay amounts, and the link button is for the tape speed. So just keep that in mind, that they work differently. And now you will always have a consistent delay amount as this changes. Now let's bring in those extra reed heads by using these two knobs here, which control the spacing and placement of the extra reed heads. Now recall, because we're talking about the distance between a reed and a right head, if delay is all the way down here, the reed and the right head of this virtual tape recorder occupy the same space. They're on the same place on the tape, so there is no delay. So let's just experiment with bringing up the sound, and I'll turn off the drums here because we just want to listen to the basic sequence. We'll turn up the feedback. You hear that echo comes in now. It's almost like a reverb effect. Oh, that is nice. And here there I can adjust the tape speed. If we slow it right down. Now you hear there that aliasing, that digital effect you get on the tape. That's a very common thing when you have digital delays. You get this aliasing if the tape speed slows down. But it's possible to turn that off and turn it instead into a lo-fi effect by using the shift button. And we haven't really talked about the shift button because it opens up controls for all sorts of additional things we can do here. So let's now use that and turn the tape speed with the shift button. And we get less of that aliasing effect and more of that lo-fi kind of feedback. So remember, this is just with the main delay head, reed head right down. So we're just playing with these additional heads. And by turning up the tape speed, we increase the delay time and create this lovely smear effect. And now I'm just fine-tuning the main reed head, richening up the sound. Add a little bit of rhythm there. Now we're just going to filter the delay path. Listen. Now it's just very much on that high end. When we bring the filter back down to the low end, we're just getting that low in the feedback path. That's just lovely. So that shows you how you can create and play. And listen, that lovely long tail there. Let's just turn that. We don't want too much feedback. You can create lovely long kind of feedback tails, like reverb tails with this by having really, really short delay times and then playing around with these additional reed heads to create those lovely delay tails. Now the last few things I want to show you, obviously we have a bypass button, which I did show at the start, but we'll just go through it again. We can bring up these. If I hit bypass, it's gone. Now what happens if I hit freeze? Whoa. We have to be careful here. Because we're frozen the delay buffer now, can kind of play it back. And now I just captured a short segment of audio there into the freeze buffer. And by turning up feedback, I can persist that, which is actually handy for transitions, like say you were loading up something else over here on a patch. Now by adding more read heads to that freeze buffer, they're not mixed into the loop, but they're added to the output. So the freeze buffer is feeding into the read heads, the extra read heads. They don't go back into the feedback loop, but here they're kind of adding to that atmospheric. That's like a very cool atmospheric for a spaceship in sci-fi or something like that. Nice, I like it. Turn off freeze and the buffer goes away. Next, let's look at one of the most powerful features on THYME Plus, which is these robots or low-frequency oscillators. And these are different wave shapes that can be mapped to different parameters to allow you to automate moving the knobs. We'll start with the patch I had previously. This is our example sound. Nice little echoey thing going on here. Don't want the drums too high so we can hear what's going on. Now, say I wanted to modulate, I don't know, the filter amount on the feedback loop. So I want this filter to turn constantly. Now I don't obviously want to do it myself. I'd like a robot to do it. To assign a robot to a destination, you press and hold the robot button and wiggle the knob, and then you choose a robot type. So let's choose the first one here, which is a basic triangle waveform. A couple of things start happening. First of all, this light pulses, which shows you the speed or the frequency of the LFO. In other words, how fast the robot is going to modulate. But all the way down to 80 seconds, real slow, and all the way up to, well, I don't know what, quite a lot. The amount knob here shows the amount of modulation taking place. The more you turn it up, the more modulation takes place. And you can see there, the filter is now blinking green and turning off. And that's that point I was making earlier, why these LEDs are so useful, because they show you where the modulation from a robot's being applied. We could also assign a robot, for example, to the delay time. So we just give it a wiggle. And let's assign a ramp. We'll assign a ramp to that one. And now we're getting you see the LED flashing here for the ramp amount. Now, what happened there was I had to catch the new amount, and now and again I want to sync that robot. Now I have two robots assigned, one over here to my filter. Remember we did that one, which is this wave shape here, and then one over here on my delay amount. Now, how do I turn off a robot? So say I wanted to turn off the robot I have assigned over here. Well, what we do is we just select it. So now that's our robot selected. Again, it's the ramp waveform. That's the one we've chosen. And we just turn the amount all the way down to 0. And now it's no longer being affected by the robot, by the LFO, because we've set the modulation amount to 0. Now, if you're at all familiar with LFOs, for example, something like Oct here, or any sort of LFO coming out of a modular system, you know they can be bipolar or unipolar. Bipolar means they go positive and negative, and unipolar means they go only positive, and indeed they can also go only negative, from 0 volts down to -5 volts in a modular setup. Same concepts apply here. Obviously we're not talking voltages, but we can press robot here and choose using the magic 3 buttons over here. You see minus, plus minus, and plus. So say I only wanted the ramp to be a positive ramp here on the delay time, so we'll go ahead and choose it again, turn up the amount, and again we see just a positive ramp only goes up. Again, I could choose it to be bipolar or negative, which wouldn't have any effect. Now, the other thing you might be familiar with from a modular setup is about wave shaping your LFOs. So you could have a very sharp attack, or you could have a very exponential or logarithmic curve on the attack. We press and hold the robot button, and this little line here, we trace it around and it shows shape. And so by pressing robot and changing the shape, I'm able to change the shape of the modulation from just a regular triangle wave to, for example, all the way over on the right-hand side, it just becomes a simple square wave, and you can see the LED illuminating there in response to the rate of modulation, which there makes it easier to see. The manual will show you all of these different wave shapes you can set. Now let's talk about these two last robot shapes over here, and that's the envelope follower and the CV input. This maps this input on the back, the CV input, to a standard Eurorack modular level. So let's go ahead and plug in Stonk over here. And what I'm going to do is use this to modulate, for example, let's use it to modulate the feedback command. So I'll choose feedback, I'll turn robot, and I'll go over here and press the CV knob as the source. And now the rate knob has no effect because we're just going to use the CV input here. And now, as you see, watch the LED there. If you see the green LED, as I move the joystick on Stonk back and forth, I change the modulation amount. So I'm going to increase that feedback. All the way up, we're getting that feedback. Now I'm going to kill the feedback. I could do the same thing with the filter, of course. Let's take that filter. And this time we're going to change the robot to be CV as well. Now the feedback loop is both high pass filtered. The last robot I'm going to show you is the envelope follower. And this allows you to track the amplitude of the incoming signal and then use that to modulate something. So for example, we could modulate the tape speed using an envelope follower. So we'll set that there, choose envelope, and the rate knob now controls how fast the envelope responds to the incoming sound. And this is obviously the amount of modulation. And let's just turn off the CV modulation I had put there. And you can see that we'll choose this robot here. So that gives you an idea of how you can use robots to modulate the parameters. And all of that would be great, and we'd have a fantastic device, but it has one additional thing on it, which is we can save each of these settings that we have, the robots, the settings of the knobs, we can save all of those to these preset slots down here, and then we can sequence between those different presets, and that's where things get really bonkers. So let's do that next. So we've been having lots of fun. We've been making all sorts of different changes and creating all sorts of different crazy combinations. And we would like to save this so that we can recall them for later use. And this is where these buttons down the bottom double up as preset slots. So you have 8 preset slots in a bank, and you have 8 banks of presets. So you have 64 in total. And you load and save banks of presets in one go. So right now we're in bank 1, and you know what bank you're in by pressing and holding the shift button, and the LED that doesn't light up, yes, it's the one that doesn't light up, tells you which bank you're in. So you're in bank 1 over here. And right now we've loaded up preset 3. So let's go back to preset 1 and load it in. So this was the sort of the reverby one I had played earlier in the video today. Then I can jump to another preset. Make it, this one changes it up a little bit. And here's a 4th one. Now, one of the best ways of using presets is to take something like, say, we load up this first one and then copy it into another slot and modify it. one thing we'd want to save is the robot settings. So let's go back to this preset here. We're going to go Shift and copy to copy it. Jump to here, Shift and paste it in. And now I'm going to change some of these parameters using the robots. We'll turn up a tremolo effect by using the filter there. I like that. And I might copy this one. And I'm going to paste it into this empty slot here. And we're going to put a robot on this head spacing. Okay. And what I want to do is put a negative modulation on that spacing. And I think we'll do a ramp. And then we'll increase the amount. Now we're getting a really crazy effect. Let's save this bank. Then we go back to our first preset. And that gives you an idea of how you just take each preset, build it, tweak it, modify it, copy and save it into a new preset slot, and then build up a bank of very, very useful transitions that you can jump between in a performance, because after all, the buttons are right here. Now, one thing that's fun in combination with presets is randomizing. So if you have, for example, Electron machines, you know that you can randomize parameters on them for crazy glitchy effects. And you can do the same thing here. It's just a different key combination. So it's robot and shift. You press and hold these two, and we can either randomize the tape machine parameters, the robot parameters, or both. So let's just randomize. Let's load up an empty preset here, which is this one. As you can hear, nothing is coming out of it. Empty preset. And let's randomize. Oh, I like that. I'm going to leave that one there. Haha, it's like a transition. Whoa. Kind of crazy, Whoa, okay, that's enough. So, by randomizing, you're actually able to create lots of really, really cool effects, and you're also able to take existing things and just spice them up a bit to make them a little bit interesting and tweak them. So if you're ever kind of stuck for inspiration, explore the randomization functions, Shift Robot, and these three buttons here to randomize different parameters. Now, one of the things you probably wouldn't expect to find on a tape delay pedal is a sequencer. Now, it's not a standard sequencer in the sense of sequencing other modules or other synthesizers. This allows you to sequence between different presets that you have saved in a bank. So, by default, if we were playing, let's listen to the dry signal here. It's pretty simple. I have it bypassed. We would just jump between different presets. So say I like this first one and maybe the fifth one. They work well together, and then I would go back. But say I want to sequence between them, and that's where these play and write controls come into play. So I'm going to hit play to put the sequencer into play mode. Once it gets a clock, you'll see the right light is flashing here to indicate that the sequencer is now running. And you see I've programmed in a sequence already, which jumps between the first and the fifth preset. Now say I wanted to add another preset in there, press right. Now we're going to jump between the first one, the last one. And we jump over there. So it's a 32-step sequencer. And I'm now live programming in different presets. And if it all gets too much, you can just turn the sequencer off by hitting play, and you'll be on the last setting that you had, the last preset you had, or you can choose a different one. But often I find unless you're getting into very glitchy stuff, it's good to just jump between 1 or 2 or 3 variations of the same basic sequence or preset. So here, these two were just variations of each other. And you might want to jump between them to create some sort of movement and sense of things changing. So there's a couple of different ways you can do it. This was live play mode, where you could actually program in live as you're playing, and then you'd hit bypass if you want to stop playing. You have different sequencer patterns here that'll jump between them linearly here. You can do subsequences, or you could pre-program in sequences by using write mode, which is where you hit write and you choose which order things play in. I'm not going to go into that in the video today because I have a couple more things I want to go through around MIDI and MIDI control, and we're getting pretty long already in what we've covered. Now let's turn our attention to the MIDI implementation on the THYME Plus. And what I've done now is I've swapped out some cables here, and we now have a MIDI cable going in here from this MIDI bolt in my modular case, which is taking the main MIDI off the Oxi One. So we're going to have MIDI from the Oxi One into the Mult, going to the Warp, going to the Fire, and also going into the Bastl THYME. But first, I'm going to show you how we can use MIDI control change messages, CC messages, to change the parameters here on the instrument. And I have to say, they have a very thorough MIDI modulation implementation. I downloaded it here. You can see it on the screen, all the different CC values. And of course, you can change the value of each of the knobs directly, but you can also change the amount of robot mapping per knob. So that allows us to combine the built-in LFOs, in other words, the robots, with an existing MIDI sequencer, which might allow you to change things up in a more performative way. Now, I'll go back to one of the presets we had earlier, which was this first one here, which sounds like this, has this lovely sort of echoey tail to it. And what we're going to do is we want to modulate the filter. Now, the filter cutoff is CC37. So what I've done is I've gone into this sequencer number 1 here on my Oxi One, and I've just mapped the LFO, number 1 LFO here, to CC37. And watch what happens now as I turn up the modulation amount in the sequencer. You start to see the LED flash. And of course, we could adjust the modulation rate. We could go even faster. And any of these other parameters as well could be modulated. So for example, we could go in here and modulate the wet dry mix. You see the wet dry mix now? This LED here is stepping in response to this curve here. CC28, for example, is the feedback knob. We could just control it manually. So you see there it turns off. Or for example, we could draw a modulation curve that looks like this. So as our pattern progresses, the modulation of feedback gets even higher and then goes back to 0 again. So that shows how we're able to control a lot of the modulation levels on the device over MIDI CC through a very well thought out MIDI implementation. But there's one additional trick we can do, and I'm going to turn off all this other MIDI modulation that we have here, and that is Karplus-Strong synthesis. Now, what is Karplus-Strong? If you have a delay time which is really, really short, you're able to kind of use that tiny amount of sound and play it like a up and down a scale using volt per octave input or MIDI notes, and play it as if it was a synthesizer. So you're taking a tiny slice of sound and using that as your sound source. The idea here is we want to have very low delay time. We can turn up the feedback, of course, and we could even do some filtering, but for now we'll just have it at this. Now, listen to the sound, and then listen what happens when I go in here to this sequencer and send MIDI notes. There's the Karplus-Strong, do you hear it? Now you might have to tune it a little bit here. It won't really work if we have the delay time up on the coarse delay knob. We're works a little bit. Of course, we can play around with all the other parameters. You hear it there, echoing in the background. Now you notice the clock light was blinking along there when I pressed play on the Oxi One, and that's because now I have set my clock source to MIDI. If we still had it on clock, nothing would happen in terms of synchronizing the time. On the Bastl THYME Plus, it would be waiting for a clock on the CV input, clock input. So let's just set it to MIDI. It can also be set to recognize MIDI start-stop messages, and in response to that, it will play the sequencer. So if you actually wanted to play the sequencer, if you presets stored in, you would hold the right button down when you're powering it up, and it would toggle on or off the ability to respond to MIDI start-stop messages. Well, I hope that overview of THYME Plus with some examples of how to use it in combination with modular systems is useful to you. Watch out for your feedback. One of the best ways of using it is combining it with both a CV modulation source like a joystick, or say this Bafako Morphader here to send in control voltages, and also MIDI modulation and MIDI sequencing from a sequencer like, say, the Oxi here. I think this is going to be something I'm going to be using a lot with some of my patches I'm setting up, especially for making those long, lovely delay tails. It's really, really good at that, and having multiple presets you can sequence through is just great for like building up different transitions in tracks. As always, let me some comments down below in the comment section. I love hearing from people, and I do try to answer everybody's questions as best I can. And don't forget to subscribe to stay tuned for future videos. Thanks for watching.